Hello guys, welcome back. So today we are going to understand about the passkey authentication in Spring Boot, similar to what we see in Google. Okay, today's world, Google, Apple, Amazon, they're all killing passwords forever because some way or the other password can be taken back or can be hacked or can be prone to brute force attacks as well. But no OTP, no SMS, and no phishing. This is what the present today's world concept looks like. Today I'll show you how you can build a Google-style passkey authentication using Spring Boot with real-world code flow and production-ready architecture. Okay, I have already used this in some of my applications which I am building in for my clients. So a passkey. Now, what is this passkey? A passkey is a passwordless authentication method based on the public and private key cryptography. Okay, we have the user device, and user device will hold the public key, and the server on the backend code, right? So that holds the public key. Now, private key never leaves the device. From the device you are trying to log in, the private key never leaves that device. It is always protected by a biometric or a fingerprint or a device lock. Okay, and it is impossible to do phishing attacks on the security mechanism that we are going to demonstrate now. Okay, now how it works, right? What is the user flow like? How does it works? And if you have seen Gmail login, at sometimes it asks are for a passkey. Okay, if you try and forget the password and click on try another way, you'll see sometimes it comes with a passkey prompt if you have enabled that, of course. Okay, I'll tell you the high level architecture flow, like how it happens. First, the registration flow. Now let's say user clicks on create passkey, and the browser creates the key pair. Okay, the public and private key pair. Now somehow we need to send that public key to the server, and private key will be there within the browser. Okay, it is secured within the browser. The browser has its own APIs. You cannot access it unless you know the login or other things, right? You cannot access it. Now what happens into the server flow or in the login, right? The server sends a challenge to the client, or let's say in this case the browser. Now the browser signs it with the private key, and then server verifies the data with the public key. This is a simple flow that works with a passkey, and this is how it works in case of Google passkey as well. Okay, now in this example I'm going to show you the demonstration what we are going to build. I have the code running. So we are using Spring Boot 3, WebAuthn and FIDO2 specifications. Basically these are the web authentication standards in the latest browsers as well. WebAuthn and FIDO2, like we call it as FIDO2. So this is supported by default into the browser as of now. Okay, we are going to use the front end for the browser auth API. So we have the WebAuthn API in the JavaScript. Okay, and we have the security challenge validation. This is the same standard that Google uses today as well. Okay, if you see, you guys can go ahead and try it. That will work seamlessly. I'm going to create a demo. Okay, this is my web application. Of course, I have just created the HTML page from the ChatGPT. Okay, and I click on create account. So I have to choose a username. So let's say I give the username as mobsf. Okay, I'm just giving sf mobsf@gmail.com. okay, so I give the device name as mobsf as well. Now I have created, I'll go ahead and create a passkey. So this is the step where the passkey will get created. Oops, something bad happened. Let me see, what is this? Okay, okay, I think the schemas are not created. I'll just go ahead and create and drop and start the schema. Right, so let's see if the schemas are got created. I'll go to my database. I'll go to the schemas, refresh. Oh, sorry, I have not created the schema. There is one more problem. The schema is passkey. Okay, so now let's go ahead and, I think this was wrong. I could have kept it as update only. It should work. Okay, let's run it and see. First we'll show the demo, then based on the demo I'll go ahead and explain some of the concepts of WebAuthn and the FIDO2, all those things I'll explain. These are pretty much simple straightforward stuff. I'll just explain you. Yes, so if you see mob sf, and it is asking me where you want to store your passkey. So I'm just saying Windows hello. It asked me for the Windows pin. I have given the pin. Okay, so the passkey is saved. Now I click on OK. You see the passkey is saved now. Okay, so this is my login and all those things. I'll go ahead and log out. I'll just click on sign in, and I don't need anything. Okay, I have not given the username as well, so let's do a sign in. I'll click on sign in using passkey. If you see, it has opened the Windows prompt. For if you want to use a Google, you can also use the Google ones or the Chrome ones, but I have used the Windows one. So if you see, it came back and it's saying you are successfully authenticated. Correct. So this is a simple demo that we are going to create. This is what, and if I go ahead and change the account email, right, let's say I want to change the email ID. So this is a sensitive operation. So for doing any sensitive operations, you need to verify your identity. So I'll go ahead and verify with passkey. Now I'll give my Windows login, and it verifies my passkey, and then it gives me a prompt. Okay, you can now enter your email address. Okay, so this is a simple demo that we are going to see in the current time, and I'll also explain you what are the few of the things like the WebAuthn and the passkeys and other things, right? Now first thing foremost, okay, simple. So why passwords are broken? Okay, why passkeys really are beyond passwords, right? How browsers, Android, hardware keys and servers trust each other. Okay, now why do passwords had to die? Okay, before we talk about passkey, let me ask you one simple question. Why do data breaches still happen in 2025? Okay, even with HTTPS, OTP, firewall, everything we have all the security inbuilt, but still some way or the other the data breaches are happening. Why? Because passwords were never designed for the internet we have today. Okay, so if your Gmail password leaks from one website, the attackers don't have Google. Okay, they log in like it is a normal user. The system thinks password is correct. Welcome. That's the real problem over here, right? Security systems fail not because of weak encryption. Okay, this is pure example, but because they trust the secrets that humans can copy. Like passwords can be copied. So the whole concept of passkeys lies behind that your private key never leaves your device. That is the whole source of truth. Okay, if that happens, then it is same like password only. Okay, but yes, now the standards, if you see the web standards, they are making sure that the private keys doesn't leave the Chrome or any device, which is in case of Android, it's the Android backed hardware keys that doesn't leave the Android device. Okay, you cannot extract the private keys from Android device unless you have a rooted access, and that in rooted access also it's very difficult to access it. Okay, now what is a passkey? It's not a password for sure, right? Basically it's a combination of public key plus private key. The private key never leaves the device, and the server stores only the public key. Now everything about passkey is built on one powerful idea, that is the public key cryptography. Okay, public key is the lock and private key is the key. Anyone can have the lock, but only one device has the key. So that is the baseline. So even the server cannot generate a valid login request without your private key. The server itself, if the server itself wants to log in, right, in case of password, if I have the password, I can log in. Correct, I can log in using your password, right? But in case of the key lies only onto the device. This is the browser, the key is only here, the key cannot be taken out from here. Okay, and this is, let's say, the server. Okay, now server cannot directly log in, it needs this key. Okay, so that is the interesting part of the passkeys. Okay, now what actually happens during passkey login? As I said earlier, it's basically a two-step. the browser, the user clicks on login, server sends a challenge. There is a challenge because it needs to know, like, server has only generated the private key, right? So that for that purpose it sends a challenge. Challenge is nothing but a simple text which can be identified by the client. Okay, and then server verifies the public key and then login success. The server never asks you what is your secret, what is your password. It never asks. It just ask, can you prove your own identity, can you prove that you own the key? That's simple thing that server asks, and that's what matters to server. If the key owned by the user, then it's good, you can log in. Now I'll talk about the WebAuthn and FIDO2, right? These are the rule book that has been defined. If you want to know about WebAuthn, you can go this website and check about the WebAuthn. This is pretty much interesting standards. Okay, the web authentication APIs are there, which you can actually go ahead and check. Okay, this is very interesting part where you should go ahead and check the latest trends and the latest login authentication mechanism that's going in the world, so that you will be able to understand what is actually happening into the security world in terms of the application security. Okay, this is one of the most hot topic, and it keeps on evolving, so you should be updated. Okay, now passkeys do not work by magic, right? They work because of two global standards. One standard is the FIDO2, which is the security framework, and second is the WebAuthn. WebAuthn is basically the browser based APIs which has been given to us as a part of the standards. Okay, this is why passkeys work. Like Chrome, Safari, Android, iOS, all these devices, the passkeys will work because it's not Google, right? It's basically a standard. If the standard is there, the standard has to be global. So that's why all those things will work into the all the devices. Okay, now there are two concepts over here. You have to understand RP and RPID. Okay, RPID. Now RP is your backend. Okay, your server, your backend server. Okay, this is a Spring Boot server, and RPID is your domain identity. Domain identity as in, like, from where the request is coming, who is the owner. Okay, and passkey, whatever passkeys are generated, right, these keys are always bounded to the domain. Okay, now each and every domain will have their own passkey on that specific device. Okay, a passkey is created for google.com, will never work on fake.google.com. okay, or on you see, right, sometimes that hdfcbank.com, and someone will create hdfcbankindia.com or hdfcbankuk.com, and they will send a phishing attack. So the passkeys won't work like that. Passkeys will only work on that specific domain, whatever is mapped from your backend, right? So that's the reason the phishing attack became very, very less, because you are relying on the passkey. So passkey gets generated onto the domain level. So that is where 99.99% phishing attack goes away, and this is an anti-phishing guarantee that the web standards are giving to you. So that's the reason it's getting more and more, very much popular nowadays. Even some of the banks which I know, some of the companies which masters in the security are changing it. The biggest fear people today have is, what if a malware steals my key? Explaining the storage accounts, basically the Android key store, the secure iOS store, browsers, all those things, right? Now this is one of the concern that you might be raising, you might be thinking, right? Now that is not a concern, I will say, because private keys are non-exportable. You cannot export the private keys. Not even the OS can read them. That is why I was saying, when you have a rooted device in Android, you cannot export the private keys. You still have the rooted access, but you cannot export it. That is the funniest part of it, and that is where the security lies. Okay, now biometric layer, fingerprint, face ID, device pin, all those things are there. So that is an additional layer of security that you are adding, right? The biometrics basically do not go to the server. Okay, so biometrics and other things, right, that stays onto the browser clients. Okay, so that is one of the more important thing that we have to understand, right? Now can we sync the passkeys, right? No, we cannot sync, and it's not needed. But I'm not saying you cannot sync. You should always have a device bounded passkey, because the risk is lower, and and it's basically very much easy in case if your application is fintech or something, right? It's very much needed and it's easy to manage, because you're not sending that passkey to the server, and you cannot send it, you cannot export the key, basically the private key, to the server. Okay, there are some concepts which you should understand, right? The attestation, the hardware backed keys. Okay, in case of Android, right, what happens specifically is the Android has a hardware backed keys. There is a concept known as strong box. I'll give you the link, you can just read it about it, as we are talking about security in detail. So I thought I'll just explain both the mobile security as well as the web one. Okay, so all those things matters. Now Spring Boot here in this case is not creating the passkey, that you have to identify, that you have to understand. A Spring Boot always verifies the proof. Okay, you are a legitimate user and you verify it using your keys. So that is what Spring Boot does. Okay, now why this passkey is being loved by most of the fintech and the banking, if you see, right, there are 4 to 5 things that is an advantage over the passwords. First is the fraud, the phishing attacks, the account takeover. No one can take your account. OTP cost, that is very minimal, in zero actually. There are no OTP cost, but yes, companies try to have an extra layer. Sometimes they add the OTP by default. Okay, so in short, we'll go ahead now and see in real time how we can set up and all those things, right? So I hope the concepts are clear as of now. I'll give a bit more in terms of the coding experience, in terms of the code. I'll walk through everything in the video so that you are able to understand how you can build it using Spring Boot. Okay, now guys, so as we have seen the concepts and other things, I'll go ahead and stop this as of now, and I'll create a next video with all the code walkthrough so that you can understand what is going on. So guys, thank you for watching and stay tuned for the part 2.